All right, as I mentioned, we have example 1, the two triads at the bottom are listed here. This was using the quadratic formula to solve for x, and I didn't hear any questions on those. Oh, I do see one now. One, if you can try number 1 on the triad. So basically, you're just using your quadratic formula, the opposite of b over 2a plus and minus the square root of b squared minus 4ac. So we have the formula. Everything is put in its place there. And we're going to go ahead and solve. Right here we have negative 6 over 4. Inside the square root we have 36 minus 24, which is 12. So I have negative 6/4 plus or minus root 12 over 4. And two things happen here for me to get from this to that. And first of all, the first part, negative 6/4, reduces to negative 3/2. Check. And the root 12 can be split up into root 4 times root 3. And the square root of 4 is 2. So it's like this becomes 2 root 3 over 4. And then we can reduce the 2/4 to 1/2. The 2 goes into that 4 2 times, so we end up with negative 3/2 plus or minus root 3 over 2. All right, so that is the triad using the quadratic formula in its entirety. And now we'll move over to example 2. Example 2 will involve using the quadratic formula and another method. And here are your other choices for another method to solve. You could graph the parabola in y1 and graph the line y equals 0 in y2 and see where the two intersect. 2, you could try factoring. 3, you could try completing the square. Complete the square. And then 4, the new method, is the quadratic formula. So the quadratic formula is definitely in play. They ask us to use, in the triad down here, the quadratic formula and another method. And for both of these today, we're going to go ahead and use factoring as our other method. So I'm going to get started here on the left side in red, and we're going to try to factor 6x squared minus 7x minus 20. So we're going to try to pull it apart into its two factors, and then we'll use the zero product property to solve for x. This is one of those problems where you do have a leading coefficient, 6, and that 6 is not divisible, or sorry, it's not a factor of 7 or 20. So this is not one of those problems where you're going to factor out the 6 first and then try to simplify from there. It's one of the problems where you'll try like maybe 6x and x, or maybe you'll try 3x here and 2x there. Trial and error. Several different combinations exist for you to try to produce 6x squared in position A, and then the minus 20 in position C. You could have a 4 and a 5, you could have a 2 and a 10, a 1 and a 20, lots of different combinations to check. I believe what we have seen throughout the day is that 3x and 2x will work to make your 6x squared. And then a 5 and a 4 will work here and here. They will multiply to make 20. One of them needs to be negative so that it becomes a negative 20. And the negative is going to go with the 5, and the positive or the plus sign will go with the 4, because we have a minus 15x on the outside and a plus 8x on the inside, and they will combine to make that 7x x negative in the center. So that is the factored form of that quadratic. Then you can set 3x plus 4 equal to 0. Or you could set 2x minus 5 equal to 0. And from there, I'm just going to run into the next problem. Keep going straight down the screen here. Here you would get x has to be negative 4/3, or in this one, x would have to be 5/2. I'm going to fill in those steps with the disappearing ink so you can see where they came from. I took away the 4 from both sides, and then you divide by 3. That's how I ended up with negative 4/3. Here, I added 5 to both sides, and then I divided by 2 to get 5/2 as the other solution. So we know the two solutions for this problem, negative 4/3 and positive 5/2. Let's confirm it with the quadratic formula. All right. Let's just make sure we get those same answers. Ready? X equals. We need the opposite of b over 2a plus and minus the square root of b squared minus 4ac also over 2a. So up here in the top left, we're going to need this right here. We're going to need the opposite of negative 7. 7. Divided by 2 times a. A is 6, so 2 times a will be 12. Plus minus the square root. Now here's where you want to use parentheses. B squared minus 4ac divided by 12. Whatever you have in this denominator, you're going to have in that denominator because they're both 2a. Okay? So let's see what we get in blue there. 7 squared is 49, minus, let's see, 4 times 6 times negative 20. That's going to end up adding, right? So I think I still have it on my calculator here. There it is. Is it the 529? B squared? Yeah, there it is. 529 should be what you get right here in blue. The square root of 529. All right, that part under the radical is 529. And that is significant because it's positive. That's a good thing. So I can definitely get 2 good solutions here. Furthermore, 529 is actually a perfect square. And it'll work out when you take the square root of it. You're going to get 23. 23 is the square root of 529. So here's where the 2 solutions will come from in the quadratic formula. First, we do 7 plus 23 and put it over 12. Then you do 7 minus 23, which is negative 16, and you put that over 12. So if you're wondering where our 2 solutions come from, if we reduce these fractions, 30 over 12 reduces to 5/2. Negative 16 over 12 reduces to negative 4/3. So we showed both problems. We showed the same problem. Both solutions showed up whether we did factoring or the quadratic formula. Any questions on example 2? It's just sort of like having 2 different tools in the toolkit so that you can solve problems in multiple ways. All right. So let's go ahead and take a few minutes here. I'm going to stop the video right here, and I want you to go ahead and do the try it on your own, and we'll check it in, let's go 5 minutes.